The topic is oops concepts in C++. We are going to see the topics inheritance, polymorphism and virtual functions. Those things we are going to see in this video. So these are all comes under oops concepts. So those concepts comes under in C++. Let's see one by one. So what is inheritance in C++? It is one of a new feature in oops concept which is used to create a new class from an existing class, whereas an existing class having lots of variables methods. So here the new class is used to inherit lots of properties methods from an existing class. So the new class is a specialized version of an existing class. So what is the benefit of inheritance? Here inheritance is used to inherit the properties from an existing to new. So automatically time will be saved, code redundancy will be saved. So lots of benefits are there in inheritance. This is one of new feature in oops in C++ concepts. So next one is here we are having diagram. Here in this we are having common insects, right? So this is bumblebee, it's having unique characteristics, right, which is used to sting, right? Here one more insect is having, that is grasshopper. So this is also having unique characteristics, that is an ability to jump, right? So these two insects comes under common class. So this is an example. Next one, the the is the relationship. Here inheritance establishes an is the relationship between classes, right? So for example, a poodle is a dog. Next, a car is a vehicle, a flower is a plant, a football player is an athlete. So these are all an example for is a relationship in inheritance concept. Next one, lots of terminologies are there in inheritance. So first we should know what is base class and what is derived class. Base class is also called parent class. Derived class is also called child class. So here base class is having some properties, that means it's having methods and functions, and derived class is also having some methods and variables, right? So here the derived class inherits from the base class. So automatically what all the things we are having in base class, those things should be inherited to the derived class. That's why base class is called parent class and derived class is called child class, right? So by using inheritance concept we are giving an example. Here class student. So here class is a keyword, student is a class name. So what are all the things we have to insert, we have to write within curly bracket. Within curly bracket we have to mention the variables and methods. So each and every class should end with semicolon. So this is a common class, this is a base class, this is a parent class, right? This is a super class. So it's having properties and methods. Now I like to drive these class into another class, that is called derived class or child class or subclass. Here one more class I have created here, class and then undergrad. So here class is a keyword, undergrad is a subclass name. After that I am using inheritance concept. For that we have to follow colon and then you have to give the access specifier. We are having three types of access specifiers: private, public and protected. If you are giving it as a private, we can use those variables and methods within a particular class or function itself. If you are declaring those variables and functions as protected, we can use in the next level alone. If you are declaring the access specifier is protected, we can derive in the next level alone. If you are declaring it as public, we can use those variables and methods anywhere in the program. So here I am using the word public I am using, so automatically we can use those variables and methods anywhere in our program. So after that you want to give the base class name. Here the base class name is student, right? Student. So automatically, so the student data will be added into the subclass, derived class, that is undergrad. So automatically what all the things, what all the methods and variables we are having in student base class, that should be inherited into the subclass undergrad, right? So this is an example for creating inheritance. So I will repeat the concept again. Here this is an example for inheritance. Class is a keyword, student is a base class name. Within curly bracket we have to give the member variables and functions. After we have to create derived class. Here in this derived class I am creating class undergrad is a derived class name. After I am using inheritance concept, here I am using colon. After that you want to give the access specifier name. If you like to give private, we can access within this class itself. If you are giving protected, we can access the variables and methods in the next level. If you declare it as public, we can access anyway. So here I am using public and then I am giving base class name. After that I am using curly braces. Within this I have to add some more data, some more variables and methods. At the end you have to give the semicolon. This is the concept of inheritance. Next is the relationship, already we have seen in this video. So here an object of a derived class is an object of the base class. So previous slide we have seen undergrad, and then here an undergrad is a student, a mammal is an animal. A derived class has all of the characteristics of the base class. What all the characteristics we are having in a base class, those things are derived in the derived objects, right? So here what is child class will do? So very important thing, what is the use of child class? An object of the derived class has all members defined in the child class, all members declared in the parent class. So the derived class having all the things what is having in this child class, that should taken, as well as it will take all the members declared in the parent class also. So it will take all the data, what all the things we are having in a parent class and child class, though both the things it will take. So an object of the derived class can use all public members defined in child class and all public members defined in parent class, right? So next one, protected members and class access, right? Here I have explained already. Protected, which is used to access the data to the next level, right? So member class specification, it is a member class specification. Like private, we can access in the next level. So we are having lots of class access specifications, private, public and protected. So private means we can access data within a class or function alone. If you are declaring it as protected, we can access the data in the next level. If you are declaring it as public, we can access anywhere in the program. So these are all comes under access specifier concepts. There are three types of access specifiers: private, public and protected, right? So next one, I have given the definition for private, protected and public. So public, object of derived class can be treated as object of base class, right? So next, protected, most restrictive than public. So but allowed derived classes to know the details of parents. We can use in the derived class alone. We cannot access anywhere as public. So we can use only in the derived classes alone when you are declaring it as protected. Next one is private. Prevents objects of derived class from being treated as objects of base class. It should be used within a class or function alone. We cannot access anywhere like a public. So here I am giving the difference between inheritance versus access. So left side we are having base class members, right side I am having derived class members, right? So here private X, protected Y, public Z. So I am accessing it as private means we cannot access X because here we are declaring it as private. Protected Y means here Y we can access in the next derived class alone. Public means we can access anywhere. Next here in this we are using protected. Here X is we cannot access anywhere. Protected we can use in the derived class. But public means we can access in the derived class alone because here we are using protected base class. Next this is public. Here private X we cannot access, protected we can use, public is Z also we can access. So here uh, uh, we are having one brief class for an example inheritance versus access, right? So here class grade. So here we are having lots of private members. Letter score. Letter should be declared as a character and score has been declared as a float. And one more method is there, void cal grade. So this is one method. Lots of public members are there. Set score, get letter. So these are all an example for class. One more class I have created here. I am using test. This is a derived class and then I am using colon keyword. After that I am giving access specifier and then I am giving grade. Grade is a base class. Automatically class grade is used in class test. Automatically what all the things we are having in grade that should be derived into the derived class test. And also it's having additional members and methods. Additional members are num questions, points each, num is those are all also included in test class. And public members test function is created, right? So then when test class inherits from grade class using public class access, it looks like this. So private members int num questions, float points each, int num missed, public members test int it. Automatically public members what all we are having in grade class that should be also inherited into test class. So we are having public members set score, and get letter. Those should be derived into test class, right? So next one here inheritance versus access. The same thing here. Same example we are giving, but the access specifier is private. When you are using derived class, a class test colon private keyword is used, right? So based on that it will access the data. Next one, very important topic, constructor and destructor in base and derived classes. So this is a special function, first special method, special function. So constructor means it is having a same name of the class name, that is constructor. We cannot call this function, it will call automatically. Whenever you are creating an object for the class, the constructor will be called automatically, that is constructor. Destructor means we are using tilde symbol in destructor function. It will be called at the end of program when an scope of object will be over, means the destructor function will be called automatically. So no need to call these special functions constructor and destructor. Whenever you are creating an object, the constructor will be called automatically. Whenever the scope of an object will be in, the destructor will be called automatically, right? So both constructor and destructor having the same name of the class name, but whereas in destructor in front you have to add the special symbol tilde. So derived classes can have their own constructors and destructors. When an object of a derived class is created, the base class's constructor is executed first, followed by the derived class's constructor. When an object of a derived class is destroyed, its destructor is called first, then that of the base class, right? So hope you understand what is constructor and destructor. Here we are having hash include IO stream. This is a header file. Automatically input output stream functions are added in this program using namespace std. After that you want to give the base class and derived class definitions. Here I am giving brief program for constructor and destructor. Here class is a keyword, base class is the class name. I am giving the access specifier public. Here I am creating one constructor with the same class name. What is the class name here? Base class. Or here I am giving base class function. So this is called constructor. So when it will call, when you are creating an object for this class, automatically this base class will be called. One more function is I have created base class, but in before I am using tilde symbol, so automatically it comes under destructor. When it will call, when the object's scope will over, the destructor function will be called automatically. So what all the things you need, you can insert within this constructor and destructor. So in constructor I am giving cout, this is the base class constructor. Next one, this is the base class destructor, right? So I am creating one more derived class. So derived class, after that I am giving colon, public is the access specifier. After that I am giving base class name, right? I am giving base class name. After that I am giving one more derived class function. In this I am giving some cout function, one more derived class. So here derived class is a constructor and destructor also created, right? So this is an example how you can call. So whenever you are creating an object for this derived class, automatically this constructor and destructor will be called. So see the program output. We will now define a derived class object. This is the base class constructor, this is the derived class constructor. The program is now going to end. This is the derived class destructor and this is the base class destructor. So it will be called automatically whenever you are creating an object for the destructor, right? So very important concept, constructor and destructor. So constructor, it is a special function which is having the same name of the class name, right? So it is called automatically whenever you are creating an object. Destructor means it's also having the same class name, but in before you are having the tilde symbol, so automatically it will be called whenever the object scope will be over. So this is an example of constructor and destructor. Next, passing arguments to base class arguments. How you can pass arguments to the base class in constructor concepts. It allows selection between multiple base class constructors. Specify arguments to base constructor on derived constructor heading. This is an example: square, scope resolution operator, square, int side. So within this I am giving rectangle function side comma side. So here I am passing an argument side. I am passing an argument side. So this is an argument, can also be done with inline constructor. So we can create inline constructor also. Must be done if base class has no default constructor. Next one, passing arguments to base class constructor. Here an example: square, scope resolution operator, square. Here we are having one argument side, and in rectangle we are having two arguments. So here square, scope resolution operator, square inside is an derived class constructor. Next one is base class constructor. This is an passing arguments to base class constructor example. Redefining base class functions. Function in a derived class that has the same name and parameter list as a function in the base class. This is redefining function. We can redefine the functions in base class. Typically used to replace a function in base class with different actions in derived class. Right. Redefining base class functions, not the same as overloading. This is not same for overloading, but parameter list must be different. Whereas in redefining base class functions, the parameters list must be different. Objects of base class use base class versions of function. Objects of derived class use derived class versions of function. Right. So this is an example. Here I am creating a class grade activity. I am having predicted here letter score determine grade. Next public, here we are having constructor grade activity, because here the class name grade activity, so automatically this constructor will be called whenever you are creating an object. Next set score, I am setting a score function created. Next get score function is created. By using set score, we are assigning the score value. Get score function, we are returning the score. So this is a simple class. After that, get letter grade, here we are returning the letter. Right. So this is an example. So this is derived class. Here we are using redefined set score function. What is the function? Set score. Here the function is redefined in derived class. Right. This is an example for deriver program. Right. So next, here we are having lots of coding. For that, we are having output. Problem with redefining. So consider this a situation. Class, base class defines a functions, x functions and y function. X function now calls y function. So we are having a base class. In this we are having two functions, x functions and y function. Here x function calls y function. After that, class derived class inherit from the base class and redefine the function y function. So I am creating one more derived class. In this I am redefining the function y. I am not redefining x, I am redefining y function. An object D of a class, derived class, is created. Here I am creating an object D for derived class, and function x is called. X is not redefined, just we are calling by using an object of derived class D. When x is called, which y is used. Whenever you are calling x function, y function is used, because y is redefined. The one defined in base class or the redefined one in derived class. Right. So this is a situation. So for problem for redefining, I am giving the problem. So here this is a base class. We are having two functions, x function, y function. One more derived class is created. I am redefining the y function. Right. So for this derived class, I am creating D object and calling the x function. Right. So this is called static binding. So object D invokes function x. Right. In base class, function x invokes function y in base class, not function y in derived class, because function calls are bound at compile time. So here function calls are found at compile time. This is called static binding. Right. Next, class hierarchy. A base class can be derived from base class. So here class A, class B, class C is having. So class is having some properties. Those properties is inherited into class B. Again class B is having own properties and also having class A properties. Automatically class B is inherited into class C. This is called class hierarchy. Class A is inherited into class B. Class B is inherited into class C. This is called class hierarchy. So consider this is one example for class hierarchy. Here grade activity is there, graded activity. This is a base class. After that I am creating two derived classes, final exam and then pass fail activity. Right. So here file exam having own properties as well as it inherits the properties of grader activity. Pass fail activity is one more derived class that is having the features of graded activity. Again I am creating one more derived class, pass fail exam. It will be derived from pass fail activity. So this is an hierarchy, right? This is a class hierarchy, an example program. So polymorphism and virtual member functions. So here virtual member function in base class that accepts to be redefined in derived class. Function defined with keyword virtual. Whenever you are using virtual member function, you should use the virtual keyword. After that you want to give the data type. After that you want to give the function name. Within curly bracket you want to give the function. Supports dynamic binding. Functions bound at runtime, that is called dynamic binding. Functions bound at compile time means that is called static binding. Functions bound at runtime means that is dynamic binding. Without virtual member functions, C++ uses static means compile time binding, right? So here static binding is called compile time binding, right? Runtime binding is called dynamic binding, right? So here we are giving examples for polymorphism and virtual. Here we are using some cout function. The parameter in the display grade function is the graded activity reference variable. It can reference any object that is derived from graded activity. That means we can pass a grade activity object, a final exam object, a pass fail exam object, or any other object that is derived from grade activity. This is an example for polymorphism and virtual, right? So here one more example, we are having some header files are included, and then using namespace std is included. Display grade is a function. In main function we are creating two functions and pass the values and they get the score for the activity. After that we are displaying grade by using test argument. So after that we are displaying the display grade function by using grade activity objects, numeric score and letter grade, right? So this is an output of this program. So here the activities numeric score is 72, the activities letter grade is C. In this example the get letter grade member function returns C instead of B. This is because the grade activity classes get letter grade function was executed instead of the pass fail activity classes versions of the function, right? So this is a static function binding. Here mm, static binding I have explained it already. So when you are having compile time binding, that is called static binding. When you are having runtime is called dynamic binding. Virtual function means it is dynamically bound to calls at runtime. So we have to use the virtual keyword at runtime. C++ determines the type of objects making the call and binds the functions to the appropriate version of the function. So virtual functions places the virtual keyword before the return type in the base class declaration. Virtual character get letter grade. This is an example. The compiler will not bind the function to calls. Instead of the program will bind them at runtime. So this is updated version. So we are giving the function. See here virtual keyword is used. What is the return type? Character. What is the function name? Get letter grade. The function is also becomes a virtual in all derived classes automatically. So this is an polymorphism. Here polymorphism is the ability to take many forms. It will take many forms. This type of behavior is known as polymorphism. So here we are having a display grade function. In this we are implementing grade concept, right? So next one is called, this is polymorphism, right? Next one is called here polymorphism requires references and pointers. Polymorphic behavior is only possible when an object is referenced by a reference variable or pointer or demonstrated in the display grade function in the before program, right? So base class pointer is very important. We can define pointer to the base class objects, can assign it's the address of a derived class object. By using pointer we can assign the address of the derived class. So right here star exam, here we are assigning the marks, and then by using arrow operator we are calling the functions. So this is pointer. Base class pointers and references only know about members of the base class, so you cannot use a base class pointer to call a derived class function. Redefined functions in a derived class will be ignored unless base class declares the function virtual. Right. Redefining versus overriding. In C++, redefined functions are statically bound and overridden functions are dynamically bound. So a virtual function is overridden, a non-virtual function is redefined. Right. So next one is virtual destructor. It is a good idea to make destructor virtual if the class could ever become a base class. Otherwise, the compiler will perform static binding on the destructor if the class ever is derived from. Right. Next, abstract base classes and pure virtual function. So pure virtual function, it is a virtual member function that must be overridden in a derived class that has objects. Abstract base class contains at least one pure function. So this is an example for pure virtual function. Virtual is a keyword, void is a data type, y is a function name, here 0 is assigned here. So this is a pure virtual function. Whenever you are declaring a virtual function, if you are assigning a 0 value to the function, that should be called it as a pure virtual function. So here 0 indicates pure virtual function must have no function definition in the base class, right? So very important one, pure virtual function. So abstract base class that can have no objects, that is called abstract base class. That doesn't have any object, serves as a basis for the derived that class that may have objects. A class becomes an abstract base class when one or more of its member functions is a pure virtual function. So we have seen pure virtual function, it's having assignment of 0, that should have a virtual keyword, and then you have to give the return type and function name. After that you have to use the equal to assignment operator, and then you have to give 0. That is an pure virtual function. Abstract base class means that does not have a objects, that is pure sorry, abstract base class, right? Next, multiple inheritance. Multiple inheritance means we are having multiple base classes and one derived classes. So automatically the subclass having both parent class properties, that is multiple inheritance. Multiple inheritance means we are having multiple base classes and only one derived class. That is an example of multiple inheritance. Here class square rect solid is a base class, class cube is a derived class. So here we are having problem. For base classes have member variables and functions with the same name. So the solutions, derived class redefines the multiply defined function. Derived class invokes a member function in a particular base class using scope resolution operator, right? So this is a scope resolution operator for invokes the member functions in a derived class. Compile error occurs if the derived class uses base class functions without one of these solutions, right? That's all. So we have seen lots of things in this. So what all the things we have seen in this? We have seen what is inheritance, right? So inheritance means we are having the properties from base class into subclass. It will inherit all the properties. So we have seen access specifiers, private, public, protected, lots of things. Private means it will access the data within the function or class itself. Protected means we can access in the next level. Public means we can access anywhere in the program. So based on that we are creating inheritance. There are lots of types of inheritance are there. Single inheritance, multiple inheritance, multi-level, hierarchical, hybrid. Likewise lots of inheritance are there. Single inheritance means we are having only one base class and only one derived class. Multiple means we are having multiple base class and only one derived class. Hierarchical means we are having only one base class and multiple derived classes, right? Multi-level means we are having level by level classes. Hybrid means combination of inheritance. What all the types we are having, we can make it combine together, that is hybrid inheritance. So by using those inheritance concepts we can inherit the properties from one class to another class. Very important one, inheritance concepts in OOPS. So we have seen lots of examples for all the inheritance concepts. So you can try yourself and write some programs in this, and then we have seen virtual functions, and then abstract classes. Lots of things we have seen in this video. You can try in your home and try your own programs by using these concepts, right? For example, if you are using single inheritance, means you have to create two classes. One is base class, another one is derived class. Multiple means you have to create two base classes and one derived classes, right? Multi-level means you can create more than one classes. One class is derived to another class. The derived class again act as a base class to the next derived class. Likewise, you want to create in multi-level, right? So in hierarchical, we have to create one base class. After that, you want to create multiple derived classes, right? So automatically base class is derived to multiple derived classes, right? So next one is hybrid. Here you can use combination single and multiple, or multiple or multi-level, or hybrid or likewise you have to make it combine together. That is hybrid, right? Very clear. So we have seen one more special concept, constructor and destructor, right? So constructor means it should have the name of the class name. The function name should have the name of the same class name. It will not no need to call this function. Whenever you are creating an object, this function will be created automatically, right? No need to call this function, it will be called automatically, right? So whenever you are using destructor, the same function class name will be declared, but the symbol we have to add in front, tilde symbol. Whenever the object scope will be over, the destructor will be called automatically, right? So this is constructor and destructor. Very very important. In critical situations we can use constructor and destructor, right? So next one, virtual functions we have seen. You have to use the virtual keyword. After that you have to give the return type, and then you have to give the function name, and then you have to give some methods, variables, member functions and variables within this, right? So pure virtual function means you have to give equal to 0, so it doesn't have nothing. So this will be declared in a base class, right? Abstract class means it doesn't have an object. That is abstract class. That is a base class. We cannot have an object for this class. That is called abstract class, right? So likewise we have seen lots of concepts in C++. So very very important one. So OOPS is having lots of features, lots of things: polymorphism, encapsulation, inheritance, and then virtual functions. Like this, lots of new features are included in this. So try to learn this and utilize in your futures. It will be very easy. Whenever you are moving to interviews, it will be very easy to handle. So try to learn those things and make yourself enhance, right? So hope this session was very useful to you. Try to learn more things in OOPS concepts, right? So that's all. If you're having any queries, you can post in comments. I will share the ideas for this. Okay, that's all, and thank you.